Okay, I'm going to try to do this, but it's going to be hard because I've only got 40 minutes. So this is the quotient rule. It's easy to remember because it's like the product rule, except this time the order of the things are important, which is why I don't like it. For instance, if you happen to put the f of x over here with this g of x and add or subtract this one, you're going to get the wrong result. So it's got to be the prime of this times the gx minus this function of x times the prime of g of x divided by g squared. This is derived simply from the product rule. They're saying, assuming this equation, well, if I rewrite this equation, and I actually like the product rule better this way, I would rewrite it like this. And the product rule says I must multiply this times the derivative of that plus this times the derivative of that. The reason I like this better is this plus means I can do these in either order and not screw it up. If I do this one and I do the f function here instead of the f prime, I will get a negative result of, not a negative, but it'll be off. It'll be the wrong direction. So if you do this, you have to memorize it. But this will become this. So here's how we do it. How do we take the derivative of that? You have to do the chain rule, which says I lower this by 1 and reduce the exponent by 1, and multiply it by the derivative of g of x, which is just going to be marked as, this. Okay. What is that? It's minus 1 over g of x squared. That's all the negative 2 means. It's over g of x squared. So now we just have negative 1 times the derivative of g of x times the function of x, like that. And then when we add this, we just replace this with this term, right? That's all that means. And this just means it goes down to the denominator. Essentially like that. There we go. Give myself a little bit of denominator. There. So this is the same as that, with a plus sign in the beginning. Now I want you to notice something. This part here is this part there. And this part here is actually this part here without that. So how would I be able to add this, since this is gx squared and this is just gx? I have to multiply this by gx over gx. And that way my denominators will become the same. And I will be left with this. Well, this is just a rearranged version of that. So if I put all this on this side and all of this on that side, I get that. But you can see how, using this method, I was able to keep track of this minus. But if I'd started with f of x up here, it would have screwed up this minus. And yeah, if you do it in the right order, it'll be fine. But the problem is, if you just add this negative up here without correctly jigging your minuses over here, it will mess it all up. Anyway, all I'm saying is be careful with your minuses, and that the quotient rule is the exact same thing as the product rule. They're just rewriting this as a negative exponent. And you better learn your negative exponents. It's very important to understand the concept of math, because if you just go around memorizing things and you make one little error, you won't understand how to fix it or where to fix it. So it's better to understand it. Okay, here we go. So I'm going to keep a clean copy of my quotient rule handy always. There's always a summary at the end of the chapter. I encourage you to spend more time on this entire endeavor than you're doing, because I think you're going to enter the test still very flustered if you don't. Okay, and I'll just keep that as a crop. And I'll try to race through these, because boy did I botch them the first time over. I actually deleted everything and start over. What are the exponent rules? Give examples of each rule. No. If your teacher wants that, ask him. That's a waste of my time. It's stupid. 2, copy the table. So all they want to do here, which is also a waste of the quotient rule, is realize that this can be simplified. And x goes into each of these things. And you're left with x plus 3, which is just a line with a hole where x is equal to 0. It's just a line. So once I write it, when I can differentiate it, I just realize that the dividend is 1. The dividend, Jesus. The derivative is 1. The slope of the tangent is 1. That's because the slope here, the line is 1. And any derivative of the line is just going to be the slope. And that x at the bottom only puts a hole in it. So over and over again, they want you to simplify. So what about this one? How can you simplify this instead of using the quotient rule? Well, this follows the exponent rule. When you're dividing two exponents with the same base, it's as if this has a 1 over it. And you can instead subtract those exponents. How do I do this? I convert it to something over 3. And I'm left with 2 over 3. So that means this whole thing can be converted to this, which means I can now use the power rule to come up with this. And now I got to lower that by 1, and it becomes minus a third, in case you don't know how I did that. When I subtract 1, this is what I have to subtract. And that negative third just means this. Whoa, it meant a lot, didn't it? This minus meant it went down there, and this third meant it's a cube root. So it's a 3 in the denominator, so it's a root. If it was a 3 up here, it would be a power. So that's all that meant. But once it's up top like this with a resolved, simplified x, I can use the power rule. Same with this one, except I'm going to convert that x to a negative. So this is the same as 1/10 times, if you want, 1 over x to the 5. And this last part is the same as x to the negative 5 over 1. That negative just says send the x to the denominator and make it positive. By the way, you can have this as well sometimes, and that negative 5 means send it to the numerator and make it a positive power of 5. So the negative just means send it to the other location of the fraction. So I can rewrite this entire fraction as 1/10 times x to the minus 5. Now I can use the power rule. So I bring the minus 5 down in front, or you like to put it here, and multiply by 1/10, and I get minus a half. And then I have to lower this by minus 6. What is x to the minus 6? It simply means take your same fraction I have right here, minus a half, and I'm multiplying it times 1 over x to the 6, which is the same as minus 1. So you can just multiply the top over 2x to the 6. So that is the derivative of that. Pretty different looking, isn't it? But it's a lot faster than using the quotient rule. What about this one? Well, look carefully. 2x can go in both of those things up above. So can the 2. Remember that if I'm going to resolve this up above, it has to go into both of them equally. So not equally, but 2 can go into the 8,4 and the 6,3. It has to be able to go into both of them. So I get rid of the 2. X can go into both of them, and this becomes squared. And this becomes nothing. X divided by x. So I'm left with 3x squared plus 3, which means that the derivative of this, which is a parabola, is 6x, a line. And remember, derivatives of parabolas, the graph of that tangent will be a line. And derivatives of cubics, the graph of the derivative will be a parabola. And that's because the power rule always lowers that power by 1. But anyway, you can see that this thing simplified very easily. So for some reason they took this section to say, look, watch for simplification before you proceed. Up above, it's a difference of 2 squares. Right away the bottoms can cancel out, so this is going to be on the bottom here. They can cancel out. And I'm left with t plus 3, which is just a line. There's the slope of that line, so the derivative is just 1. Don't know why they did that. And then they said, what are the different ways to do that? Well, simplifying is above. The product rule that I did, where I made the exponent negative, or use the quotient rule. Part B. Now, I made so many mistakes going through this. So here's what you're going to do. Always do a clean sheet and put down your question. Okay, and I'm going to do 2 of these. So here's my question. Use the quotient rule and simplify. So I'm not going to do the first one because it's easy. Let's do this one because it's hard. So first time, write down your function like that. Next, bring up the quotient rule. Bring a clean copy of your quotient rule. I don't even need that one. The second one, there's my quotient rule, clean copy. So I'm just going to take this clean copy. Well, you might say, oh, God damn. You might say that, well, I don't have any f of x or g of x in any of these. Fair enough. So I'm just going to make this larger. So you can assign the top as equal to f of x and assign the bottom in a bracket as equal to g of x. So I strongly suggest, after writing down this, that you just simply assign them. So I'm going to make my f of x here and my g of x. And I'm just going to move it all up a bit so I have a bit of room. A little less than that. Okay, won't have to waste time doing this. And I'm going to make my g prime of x. I've already mushed it up, so I'm going to make it better. Nope. I'm going to make a better version of that one. And I'm going to make a g prime of x. And actually I'm going to put the g primes and the f primes together so that I know which one I'm working on. And then I'm going to assign f of x is this equation and g of x is this equation. And you know what? I'm going to put brackets around them. Okay? And I'm just going to put an equals so I don't get confused. And then I'm going to work out, and by the way, I put this in the wrong location. And then I'm going to work out what the derivative is of each of them using the power rule. If you're not fast at this part, at this stage, boy, you better just really work on the power rule over and over again. You should be able to see right away. 6x cubed, the derivative is 18x squared. Fast, fast, fast. Okay, and now that I have it like this, I'm going to take each item, and I'm going to make sure they're in brackets. I'm going to take each item, and I'm going to replace them where I see them. So here's f prime, and I'm going to put it here. And before I do that, you know what? I'm going to stretch this out nice and long. Beautiful. So I'm going to put f prime here. And there's none of that in there. And I'm going to put g of x here. And I'm going to just move it all a bit to the left and clean up some of the stuff and make sure to put that minus back. Because most of my errors are from that. And then I'm going to do my f of x here. I'm going to grab my brackets too. And I'm going to put my g prime of x here. I'm just going to quickly look and make sure it's good. It matches. And then here, I'm going to open this up nicely, and I'm going to put my g of x squared. Now, they want you to simplify. And you won't rarely have to simplify, because right now, this is a working derivative formula to find the tangent for that function right there. You could just plug in values of x. Let's say they said, I want to find the tangent when x is 2. I can just plug in 2 over and over again. This is minus, by the way. And look at that. I stole the thing. And I can just plug in the x values over and over again, solve here, and just make sure I'm multiplying them, and then multiply these two, subtract them. That's what the quotient rule says. And square the result of this. And then take the top, divide by the bottom. So that's very easy. But here they say the word simplify. We're going to leave the bottom as it is because it's pretty damn simplified. And we're just going to expand the top. Okay? 6x to the 4, and that was a minus. Always just look back at your original equation. Minus 3x squared minus 4x to the 4. So we can get rid of all this, and we can just clean this up. Always try to make it as clean. I'm very messy, and I'm unfortunate. And I encourage people to make clean, orderly notes, and I'm going to do something where I do that. However, I have apples and oranges up here. These are apples. What's 6x4 minus 4x4? It is 2x to the 4. So there we go, and I can just get rid of that one. Boom. Now you could take x squared out of both of them if you wanted. I don't know if I see the point of doing that. Maybe for simplicity of solving it, or super simplicity, and that would be super simplistic. However, sometimes if you see this in a bracket down here, for instance, if this, instead of saying 3, had said 1, you could cancel one of them and just leave 1 down here. But it didn't. Okay? Because when I took the x squared out, I'm left with the 3. But you can see that. Now let's just make sure that that's the answer. So we were doing 4C. So we're just going to grab 4C. And they have this. Yeah, they left it, see that? I had it like this, squared, but they left it expanded. And they left the bottom as is. So there you go, that's a derivative formula. So I'll just go back to the way I had it originally. That's how they have it in the book. So that's a derivative formula that, again, you can plug in x, but notice how long it took me to simplify it. Pain in the butt, right? I do not encourage you to bother with simplifying it unless your teacher wants to see you do the work. So I'm going to take another hard one, and I'm going to do the same thing. I'm going to assign the top as a function called f of x. I'm going to find the f prime of that, which is 2x minus 1. And then I'm going to assign the bottom as a function called x squared plus 3. And I'm going to put it in brackets. And I'm going to find the derivative of that, which is 2x. And then I'm going to go get a nice clean copy of this. And I'm going to, this is the quotient rule. And I'm going to expand it, and there it is. And everywhere I see my values, f of x goes right over here. G prime of x goes right over here. Wish I had brackets for it. But that's good enough. F prime of x, and look at that, I forgot to leave a copy. F prime of x goes right over here. And g of x goes right over here. Now, I'll do that. And now I'll just get rid of the fluff. And there. Now your book will want you to expand because he says simplify. Now I'm not going to do the other ones. This one's fairly hard. This one here, I would expand it first before assigning that as f of x. A lot easier. You can do the product rule up here once you put it in this equation, but you're asking for a headache. Why not just expand it first? Then you can assign it as f of x. Okay, so distributing this, I get 2x cubed plus 6x minus x squared minus 3. And before I assign this minus, I'm going to distribute this in one big bracket first. So I get 2x cubed. So remember, there's a big minus here. 2x cubed minus 2x squared. That's that one there. Plus 2x. Now I'm going to assign the minus through it. So the first one becomes minus 2x cubed. The second one becomes a positive. And the third one becomes a negative. I've now correctly gotten rid of those brackets, and I can replace all of this with there. But let's look at my apples and oranges. I've got 2x cubed minus 2x cubed. Let's get rid of them. I've got 2x squared minus an x squared. So that's just going to leave an x squared. So let's get rid of them. I've got 6x minus 2x, so that's going to be plus 4x. And then I have a minus 3. And if I could factor that, plus 3 minus 1, no. I would, but I believe that this is going to be what the book says is the simplest form of, which one were we doing? We were doing f. So we're going to see what the book says. And it says this. Got it. Okay. So it's much easier to assign the top as f of x, assign the bottom as g of x, work out the derivative of both, pull up the memorize or pull up the quotient rule right here, or memorize it. It's fairly similar to the product rule, except there's a minus here, and you have to get things in the proper order. And this is always the bottom one. That's not prime. This one is always the bottom one squared. Yeah, worth memorizing. However, there's so many things to memorize. All right, let's keep going. I only have 18 minutes. I'm not going to do all those because it's the same thing, right? Now, then they ask you this one. They ask you 5 rather. They say, now I want specific values. I'm going to just get rid of the other one. You don't need me to do those over and again. It's the same method I just did over and over again. So I'm showing you 2 methods. You do the rest. So here, now they're going to do the same thing, and I'm going to do this exactly. Well done, Peter. That was useless. And I'm going to take my formula. I'm going to put it in a nice spot. So this is the one I'm working on. And we're going to do this one too, and I'm going to just show you that you should just expand it. And the rest we're not going to do, okay? Because it's the same process. And I'm going to, this time they just want the x. And I'm going to pull up a nice clean copy of my, look what I did, eh? It's not even clean anymore. Nice clean copy of that. And I'm going to put it in a nice spot. And let's leave that over there. So I'm going to put a nice copy there. And then I'm going to assign all my f of x's. I'm going to call f of x. I'm going to say g of x, the bottom one, and I'm going to say g prime of x at the bottom, and I'm going to say f prime of x right there. And you're going to label it better than I did, and you're going to assign the top one as f of x, and the bottom one as g of x, and then you're going to write down the derivatives. This one's a 3, this one's a 1. It's always nice when it's a 1. And then you're going to take a nice big copy of your quotient formula, like that. And you're going to make it nice and big. And wherever you see the terms, you're going to replace it. But this time we're not going to simplify. So where do I see f of x? Right there. And where do I see, and by the way, look what I did and didn't do, brackets. And then g of prime of x, which was there, is just 1. So I can get rid of it. And then up here, I need my prime of x, my prime, f prime rather, and it's going to be multiplied in brackets by my g of x, which goes there. And also, it goes there. Boom. Now, stop. Don't expand. Don't simplify. I can now take minus 3, put it in there. Minus 3 plus 5 plus 2. Minus 3 times 3, that's minus 9 plus 2, minus 7. Minus 3 plus 5, 2. 2 squared, 4. So, I'm going to multiply this out now. I get 6 minus 7, 6 plus 7. 13 is the top. That's the top number for all of it. This came out as 2. What is 2 squared? 4. So I get 13 over 4 is the slope of the tangent when x is minus 3 for this function. And that's how you do it. Let's see if I got it right. Yeah, I did. Right there. Okay. Now I'm just going to pull that one up. Make sure I get the other one right. Great. Delete, delete, delete. Now I'm going to work on this one. Okay. I'm going to do the same thing. I'm going to put the answer down though. That's the answer. And I'm going to pull up a clean copy of my quotient. I'm going to put her down. might as well stretch her out now. And on the left, I'm going to assign my f of x, maybe a little smaller, and my g of x, maybe a little smaller. And I'm going to make my g prime as well. And I'm going to make my f prime as well. I'm going to put a big old symbol here. And I'm also going to use the brackets. But if I were to expand that, I'd have to use the product rule. Or I could just expand it. And it's x squared plus 3x plus 3. Great. Or I can keep it as is for f of x. It's up to you. But I like expanding. So let's just keep it up like that for now. And then I'm going to keep that as g of x right there. It's got nice brackets on it. Now, I got news for you. If I was to use a product rule, and I know that the derivative of that one is 1 and the derivative of the second one is 1, I can just add up all their x's and numbers. It's going to be x plus 1 plus 2. It's going to be 2x plus 3. Just do 1,000 of them and you'll get used to that. If in doubt, look at this up here. 2x plus 3. See? And that's only when their derivatives of both those things are 1, because then the product rule doesn't matter if I'm multiplying by the derivative. Okay. I know that this then is 2x plus 3. And I know that this one's going to be 2x minus 3. And then everywhere, and try, when there are two terms like that, put them in brackets, because otherwise it'll get way too confusing. So everywhere I see my g of x, I'm going to put it like that. And because it has its own nice brackets already, I'm not too worried about it. However, I have to remember that I'm going to multiply them together before I square them. Then I can see that I forgot to leave a copy here, so I'll bring it back. And then I'm going to take my f prime here, and I'm going to multiply it by, and I'm going to forget to take a copy. And I'm going to multiply it by my g of x. So now you can see the problem without expanding first is I'm going to have multiple. Except that I'm going to solve for x without expanding. Then I'm going to subtract my f of x times my g of x prime. Great. So the good news is we don't have to expand it. We just have to plug in the number 4. So I'm going to solve each bracket in red, okay? 4 over and over again. That's 10, 3, 2, 5, 6, 5. 10 times 3 times 2, 60. 5 times 6 times 5, 150. 60 minus 150, negative 90. The top is negative 90. Bottom, easier. 4 minus 1, 3. 4 minus 2, 2. 2 times 3, 6. 6 squared, 36. Minus 90 divided by 36. Both of them can be divided by 13, I think. But if you don't know that, just start with, you know they're going to be divided by 3. So start with 3, and you get minus 30 and 12. And then you can see, oh, they're still divided by 3. And you get minus 10 over 4. And then you can go, oh, they're divided by 2. And you get minus 5 over 2. Oh, I got the wrong thing. So I did a division wrong somewhere. So 4 minus 1, 3. 4 minus 2, 2. 2 times 3, 6. 6, 12, 18, 36. That's correct. I got the top wrong. 4 times 2, 8 plus 2, 10. 4 minus 1, 3. 4 minus 2, 2. 2 times this is 6. 6 times that is 60. That's 5. That's 6. That is 8 minus 3 is 5. 30 times 5, 150. No, I got it right. So minus 90 over 36. If I divide them by 2 is minus 45 over 18. If I divide them by 3, it's minus 15 over 9. If I divide them by 3 again, it's minus 5 over 3. So I did something wrong somewhere. Let's check out my derivatives. X squared plus 3x. So the x squared will be 2x. Did I put in the right thing? Did I put in 3? I read it as 2, but that's 3. So that's going to be adding 11. So that's going to be 11 times 6, which is 66. There you go. And so that's where you can see, because of my sloppy writing, it gets me into trouble over and over again. So I get 66 minus 150. And I can tell you right now that's going to be minus 84. Big difference. So I got minus 84 over that. And if you're not sure about factoring, start with just 2. So I get minus 42 over 18. Oh, it can be factored again. Minus 21 over 9. Oh, they can both be divided by 3. Minus 7 over 3. So that all came about because instead of writing plus 3 there, I sloppily just scribbled that. So that's why dragging these down like this is a lot more accurate. So I just have to be careful when I do my writing. So boom, that's correct. And I did not have to simplify. I just could expand it. All right. Determine the slope of the tangential curve at this particular point. Well, we just did that. Same steps. You take your formula. You make a nice clear copy of your formula. You pull up your nice clean copy of your quotient. Make it big. You assign f of g to the top one, f of x rather, to the top of one. Then you assign g of x to the other one. Okay. Look for simplification first. There is none in this case. And then you do f of prime. And you do g of prime. Okay, and I got to learn from the last time. G of prime, f of prime. Put it in brackets. Put it in brackets. What's the prime of that? 3x. See, look at that. 3x squared, brackets. What's the prime of this one? 2x. Now, expand your quotient. Make it nice and clear. Everywhere you see f of x, put in this. Everywhere you see g prime of x, put in this. Everywhere it's 2x with a bracket. Everywhere you see f prime, put in this. Everywhere you see g of x, put in this. And then don't forget to put it in down here too. So now, interestingly enough, this point that they give you y is only useful if I had to derive the line or something else. All I need here is the x to figure out the tangent, the slope of the tangent for this graph at x equals 3. The 9's not even useful. So I'm going to insert it each time. 3 times squared times this, and in blue, 27. 3 squared, 9 minus 6, 3. 3 to the 3 to the cube, 27. 2 times 3, 6. So these multiply and these multiply. Down at the bottom, 3 squared minus 6, 3 squared, 9. 9. So 3 times 27, 81. 6 times 27 is twice of that. So it's 162. When I subtract them, I get minus 81. So now I have minus 81 divided by positive 9. You're always going to get a positive down here because it's always squared. Okay, that is the same as minus 9. So let's see if the answer for, that means the slope of the tangent, so it's going downwards, for x is equal to 3 for this function is minus 9. Let's go see if we got the right answer. So this is question 6. And where are you, question 6? Looks like we didn't write you down. And I think you're on page 638. Almost. There it is, minus 9. As long as we're here, let's grab some of them. Okay, and make sure we have them all. The reason I got the answers now is because I'm sick of finding out later I've made a mistake. Grab that. And yeah, okay, I just need 6, 7. So I'll just make them a little bit there. 6, do I need that? There we go, that's good. And I don't need 9, I got it up top. Okay. Good. Oop. No. Good. That's fine. Didn't quite get it all, but that's okay. It doesn't matter. Boom. Got that. Got 6. 7. Let's see if it's any different. Oh, got to go back now. It was on page 89? No. 99. Close. Okay, so determine the points on the graph. So this time, instead of telling you the x value, they told you the result of the tangent, and it's going to be a little bit trickier. It can take a little bit longer. But it's the same technique. Write down your equation. Write down a clear copy of your quotient formula. Assign the top value. I'm just going to grab another copy. This is going to be f of x, and this is going to be g of x. Okay. And I'm going to make sure I use brackets. This is going to be f of x, and this is going to be g of x. Okay. And make sure you put it in brackets, and then do the derivative. So f prime is going to be 3. And g prime is going to be 1. It's always nice when g prime is 1. Once you've done that, your next step is we're going to replace it wherever I see, and the g prime is 1. So there, that. And you'll see the extra step here, and g of x squared. Right, so that's fine. And then up here, I'm going to have the f prime of this times the g of x. And notice I lost the f prime in the formula, which is fine. There you go. So, put it back. So, and it's always good to keep this here in case you make a mistake. Now, we do not know, this is a case where we're going to have to expand because they didn't give us an x value. They just told us this whole slope, this is the slope equation now, 3 times this minus that times this. We might as well expand it. We get 3x minus 12 minus 3x, because this is a separate minus, it's not being multiplied by that. This was the right side of the quotient. So always good to keep a quotient equation up here. You can see 3x minus 3x, I'm just left with minus 12. Down below, the square of that, which is this squared, is x squared minus 8x plus 16. So this is the simplified equation. It is all, they don't tell us the x value, but they do tell us it's all going to be equal to this slope, because this is an equation for the slope. And here's one of the toughest things most people have. You need to get this x value up to the numerator to solve it. Now you can't put a minus exponent here because it's all part of this thing. You can't put a minus and just bring her up here because that doesn't help me. It's in a denominator. If this was just 1 over 9, how would we get rid of the 9? We'd multiply by the reciprocal on both sides of the equation, right? So just treat that whole thing like one big old number. Oh, I got to stop after this one. So one big old number. So I'm just going to move it over a bit. So I'm going to multiply this whole thing by the reciprocal on both sides. You must always multiply by the reciprocal. Hang on. You must always multiply the reciprocal on both sides. And just assign this minus to the 12th. All right, what happens on the right side? Cancels out. That's what we wanted. We're trying to get to the x squared on top. That's all we did there. So we're left with this. And now since both these things are multiplying each other, I can rearrange it like this. And just leave that as one big number. it's being multiplied. This bracket, which I can't solve yet, because when you're unraveling, you're doing reverse BEDMAS, which is SAMDEB. Okay, I can't get into this bracket until I do the other stuff. So it's being multiplied and divided by this. So I want to get rid of it by multiplying it by its reciprocal all at once. See, look what happens. Cancel, 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 cancel. So if I'm multiplying this right side by its reciprocal and knowing it's going to disappear, or sorry, left side, then the right side must be multiplied by as well. Keep in mind this is being multiplied now. Use your little dots. It's easy to see that the 12s cancel, and I'm just going to be left with a minus. What's a minus times a minus? I'm going to be left with plus 25. So that means I've got x squared minus 8x plus 16 is equal to 25. Let's bring the 25 over to this side. I got x squared minus 8x minus 9. It's equal to 0. Nice. That can be factored. Does it make sense that there are two possible tangents that are going to be equal to this? Yes, it does. Because as you know from your experience, this is a graph, and it always helps to study to look at what you're studying. This is going to be a rational function with a asymptote where x is equal to 4, and therefore it's going to have, and the horizontal is going to be at 3. Better figure out how I figured that out, because that's last year. And that means I'm dealing with something here and something here. Now, I want you to pay close attention. If I draw a line, I can fit that tangent here and here. If I make my line more steep, I can fit it there and there. So these kind of graphs will always have two tangents on them. Same with cubics. They'll have two of the same tangents. And to the power 4 can have 3 of the same tangents. Power 5 can have 4 of the same tangents. And you got to learn that some of these have multiple tangents that are the same, and that's where recognizing the graph is good. Well, when I factor this, I get x minus 9x plus 1, which are the factors, which means that when x is equal to 9, this whole bracket makes a 0, and when x is equal to minus 1, this whole bracket makes a 0. Well, they asked me for where, determine the points, and by the way, the clue was S, points. Well, that means I've got to now take my original equation, which was this, and I need my y values. Notice the book always uses y, but your teacher's always going to be using f of x. Well, if I put 9 up here, I get 27. If I put 9 down there, I get 5. So that's my y value. If I put minus 1 up here, I get minus 3. If I put minus 1 down here, I get minus 5. So that's just 3 over 5. That means when my x is 9, my y is that. When my x is minus 1, my y is that, which means my points are this. That's a 9, by the way, comma, that. There are my 2 points that fit into that graph. Let's see if it was right. So we got, see if I can remember them. Right there, 9, 20. Yep, got them. Got them. Okay, that's how you do it. So in this case, they gave us everything the other ones were giving us, except in telling us, instead of telling us the x value, they told us the slope. And that may mean we had to practice unraveling an equation. You better get good at it. It's part of science. It's a major part of science. It's part of chemistry, part of physics. Now, I don't think they should teach calculus for biology, but what it does teach you is how to interpret data, and biologists get a lot of data. So that's it for now. I'm up to question 7, and I'll continue in a